Hello and good day, Algebra. Here with you to go over math packet number 11, your second to last math packet of the year. It is due on May 4th. So this first page here, and we did go over this in class, so just kind of to recap what we talked about. What this table is saying is that the sum of each row, so these four symbols, whatever number they represent, add to be 23. These four add to be 18. These four add to be 24. These four add to be 15. And then going down the columns, this first column adds to be 24. The third column, they add to be 17. These add to be 25. And ultimately, I would like you to tell me what the sum of that second column is. Okay. And so we kind of talked about, well, there are no numbers given here. So what are the parameters and where do we start? Well, first of all, none of the numbers are negative. None of the numbers are zero. And they're all single digit numbers. Okay, so that kind of narrows it down significantly for you. We also talked about how kind of the best column to start with is that first one there. Because in that first column, you've got three like symbols, which means that three of the numbers are the same. So 3 of the same number plus the pound sign equals 24. And given the limitations that I just described for you, I mean, the at symbol obviously can't be 9, because 9 plus 9 plus 9 is 27, which is already larger than 24. And since the pound sign can't be negative, you can't have a negative 3 there. So 9 is out. 8 is out for the at symbol as well, because 8 plus 8 plus 8 is 24. And since the pound symbol can't be 0, okay, the at symbol can't be 1, because that would only be a total of 3, making the pound sign 21, which it can't be because it's a single digit number. So that's a good place to start. And you'll find that there are basically 3 options that the at symbol can be. And once you kind of narrow it down to those 3 options, now you can kind of look at it as a little bit of logical guess and check. Test one of the options, see what the pound sign is, and then from there, I would go to this second row, because if you're assuming the at symbol is something, you've just figured out what the pound sign is. Does that work to make 18 with the euro symbol or the pound symbol or whatever symbol that is? Okay, so you will find that there's only one option that fits, that works for everything, and that's ultimately what you're looking for, and then getting the sum of that second column there. So that's how I would start it, and I recommend that you do the same. The next page. The Euclid is given to 8th graders who average 90% or higher on their tests. This is an actual thing at the end of the year for 8th graders. If your test average is at least a 90%, there's also a condition with the math packets also, but you can win the math award, which is the Euclid. It's a nice plaque with your name on it and everything else. Anyway, Sharon's first 7 test percentages are 95%, 81%, 79%, 89%, 92%, 94%, and 81%. With 3 tests to go, is it possible for Sharon to earn the Euclid? So right now, if you calculate her test average, she is below 90%. So with these 3 tests, is it even possible, if she maxes out at 100% on each of those 3 tests, because we are assuming it's not possible to earn extra credit. So the highest score she can get on each of those 3 tests is 100%. If she maxes out, will she even get the Euclid? Will it be enough? Okay. And then whether it's possible or not, what is the highest test average that she can get with 3 tests to go, given what she's already done? Sorry for the dead air. I got a phone call that I had to answer. If I knew how to edit these things, then I would. But otherwise, hopefully you survived. Okay. Anyway, so that's what I would do with this second one. Third one here, 5-card challenge. We know about that. You need to get at least 18 points. Have one equation with all 5 cards. Yeah, kind of same thing as every other packet here. The next page, identify expressions or equivalent to the given expression, defend your decision. So this goes back to FOIL, crab claw, box method here, multiplying binomials. And we're squaring binomial x minus 10, which literally is x minus 10 times x minus 10. So there's a gift for you. This one is equivalent to the expression because it follows the definition of what a power is. So from there, you could FOIL, crab claw, box and see which of the other 4 expressions, how many of them, if any, that you come up with. Otherwise, another option is to plug in a number 4x, solve the original expression, and then plug that same number in for x in each of the 5 possible equivalent expressions and see if you get the same thing. Of course, be careful with what number that you pick. Typically, when you plug in numbers for a variable, just to test something, you want to stay away from 0. You want to stay away from 1, just because those numbers have so many quirky rules to them or exceptions to them that you might run yourself into trouble. But make sure you defend your decision on this one. Shaded area. You're looking for the area of the entire figure, which is the large circle. The diameter of that large circle is 75. The diameter of each small circle is 30. So the whole figure is the large circle there, and then the shaded area is the gray section inside. And these dotted lines here serve to connect the radiuses of each of those 4 circles to make a square. That's going to be very helpful when you're looking for the area of that shaded section, because the square is made up of the shaded section, which is what you want, and then 4 quarter circles, which when you put them all together equals 1 full smaller circle. So my game plan, if I were going about this, is I would use the information here to get the side lengths of the square, calculate the area of it, subtract the area of 1 full smaller circle, and that's going to leave me with that shaded section there. Okay? See what you can do with that one. Next page, pattern blocks. Taking a little bit of a step back, actually, in our pattern blocks. The last several that we've had, the patterns were not hidden, so to speak, but not easily seen. This one, the patterns are pretty straightforward once you start to fill out. So fill out the green column for the first 4 figures, the blue column for the first 4 figures, the total blocks for the first 4 figures, and I'm confident that with a little bit of study, you'll be able to identify that pattern and roll with it there. So complete the table through figure 8, and then your question for algebra, how many blue blocks will be in the 10th figure? Blue blocks in the 10th figure. Next page, we have our surface area question. All classes, including you, draw a net and label its sides. We have a rectangular prism, so we're kind of back to that Amazon box. You know it has 6 faces. It's got 3 pairs of congruent faces, the front and the back, the left and the right, and the top and the bottom. And your question, given the volume is 135 cubic units, find the value of x. Okay, and in class we talked about algebra especially, geometry too, but algebra especially. When in doubt, find a relationship. In an algebra, that relationship is going to be an equation. And what equation are we going to be using here? Well, since we're given the volume, let's use the equation for volume for a rectangular prism. The volume is base times width times height. That's the relationship between volume and a rectangular prism. Now let's fill in what we know. We know the volume is 135, that's given. Looking at the figure, we see the base is 5, the width is 9, and the height is x minus 1. And what we've just provided ourselves is an equation that we can solve. 5 times 9 times the expression x minus 1 equals 135. So you can take it from here. But don't forget to draw that net of the figure as well. Next page, the Magnificent Seven, the 7 solid figures we've talked about relating to volume. I give you the volume for each figure. You need to give me the formula as well as what each value, length, width, height, radius, or whatever is to get the given volume. And in algebra, you need to be doing 4 of the 7. Next page, shoot for the moon, your math exploration. You're lying in bed one night, unable to sleep, having counted more sheep than you ever imagined could exist. You begin to ponder something else. You take off your comforter, which is about 1/8 of an inch thick. That decimal correlates to 1/1/8. You fold it in half, making it 1/4 inch thick. Fold in half again, it's now 1/2 an inch thick. How many times do you need to fold it if you want to make the comforter thickness equal to the distance between Earth and the moon? So obviously a fictitious example here, but getting to the fact that whenever you fold something, the width of it doubles, right? Because you're folding it over on top of itself, okay? And so essentially, starting with 1/8 of an inch, which is the given thickness, after one fold, it's 1/4 of an inch thick. After 2 folds, it's 1/2 an inch thick. Your third fold, now it's 1 inch thick. Fourth fold brings it to 2. Fifth fold, 4. Sixth fold, 8. Seventh fold, 16. Eighth fold, 32 inches, and so on and so forth. How long will it take, if it doubles each time, how long will it take to get to the thickness from the Earth to the moon? And so I give you the necessary values to convert the distance from the Earth to the moon in inches. The moon is 238,900 miles from Earth. There are 5,280 feet in a mile, and there are 12 inches in a foot. So with those numbers, you can convert miles to inches and figure out how far that distance is. And then each fold doubles the thickness. How long will it take for the comforter thickness to surpass the distance? So you're not going to get an exact value to match here. It's going to be at some point, it's going to surpass that distance from the Earth to the moon. How many folds will that be? Here's a hint. It's not going to be this one here. So you can't just count how many lines there are and call it that. Okay, it ends sometime before that. In actuality, humans can only fold something 7 times in half, or 8 if you've got super strength. But it doesn't matter how big that something is. If it's just a loose leaf piece of paper, or a blanket, or a large piece of bulletin board paper, whatever it is, you can only fold it 7, possibly 8 times. In theory, though, it was only in 2001 when Brittany Gallivan said that it's possible to actually fold something 12 times if you take into consideration the substance lost in the folds themselves. But your job, how many folds will it take that comforter to get from the Earth to the moon? Next page, mean, median, mode. You get to be a little bit creative here, as creative as you can be with just writing down numbers. But create a data set of 9 numbers that has a mean of 56, a median of 48, and a mode of 36 and 86. So if we recall what mean, median, and mode are, mode is the number that shows up most often here. So your data set has to have at least 2 36s and at least 2 86s, right? Because they both have to show up the same number of times and the most. So there's 4 of your 9 numbers already. A median of 48 means that 48 has to be there too, in the middle. So there's 5. So really, you're just writing the other 4 numbers of this data set that will give it a mean of 56. 56 doesn't have to be a number in your set necessarily. They just have to average to be 56. However, the other ones, 48, 36, and 86, they've got to be in there based on the definition of what a median and a mode is. Okay? Then finally, your polyomino question. You know how this one goes. Each of those 10 figures appears in the figure on the right exactly as they are on the left. Your job is to tell me where each one shows up. This packet is due May 4th. Please turn in early for me to check over. It will help help your score and give you a step in the right direction. So that's how you math. Don't forget to like and subscribe. Thanks for watching. And of course, have a great day.